Hi students, how are you? In our previous video, the topic that we are discussing with is the variation or deviation from the Raoult's law. Is it not? There are some solutions that are showing positive deviation from the Raoult's law. Let us recall what is Raoult's law first of all. Raoult's law. What is Raoult's law? We are just recalling the points that we have learned previously. What is Raoult's law? Raoult's law means it is explaining that in a binary liquid solutions, the partial vapor pressure is directly proportional to the mole fraction. Means if at all a solution is made upon two components. Let us say these are the two components. These both are liquids only. According to Raoult, these both are liquids. Which kinds of liquids these are? These are of volatile liquids. What are these? Volatile liquids. Means that will be easily evaporating into the vapor state. So we say in a binary liquid solution, the partial vapor pressure is directly proportional to the mole fraction. Means the pressure of A, partial vapor pressure of the component A is equal to or directly proportional to the mole fraction of A in the solution. That is what Raoult had given. That is the main thing we had discussed. And also we had discussed that there is a graph given by Raoult. The graph is with vapor pressure and also mole fraction. Vapor pressure and the mole fraction. Is it not? And he also explained, for example, if at all now the case is changed. How is the case changed now? There is a non-volatile solute. One of the substances is a non-volatile solute dissolved with volatile solvent. This non-volatile solute is having a PA0. That the most volatile solvent we can say it is PB0. Means there is a steep increase in the total vapor pressure. Here it is, in other words, you can speak, instead of taking non-volatile, this is less volatile. That is what Raoult mentioned. In the case of two binary liquid solutions, one is less volatile and another one is more volatile. Less volatile will have less vapor pressure, more volatile will have more vapor pressure. And we got this graph also regarding Raoult's law. Then again we learned that there is a positive deviation from the Raoult's law and there is a negative deviation from the Raoult's law. Those are the main basics that we have learned. But now in this topic we are going to discuss about something azeotropic mixtures. What are azeotropic mixtures? Remember children, when we are going to prepare alcohol from the sugar cane. Yes, when we are going to prepare alcohol from the sugar cane. This sugar cane, the juice from the sugar cane, upon fermentation, it is giving the alcohol. They had obtained this alcohol in a ratio of 95% of ethanol and 5% of water present in it. What is the alcohol they had obtained after the fermentation? After the fermentation of this so-called the sugarcane juice, we can extract the alcohol. That alcohol is having this composition. Even if it is passed on the fractional distillation, it is occurring in this composition. Please observe here. In general, the boiling point of ethanol is 78.5 degrees Celsius. Yes or no? And these two together, when they are present, means ethanol of 95% and 5% of water, means they are present in some fixed composition. They are present in some fixed composition. They are present the fixed composition both in the liquid phase and also in the vapor phase, and they are now together. Actually, we know the boiling point of water is 100 degrees Celsius. Everyone knows that. Boiling point of ethanol is 78.5, but boiling point of water is 100 degrees Celsius. The compounds basically which they have difference in their boiling point, but under a fixed composition, they are going to boil at a same temperature. They are going to boil at a same temperature. These two together at this composition, they are going to boil at a temperature of 78.15 degrees Celsius. At what temperature are they going to boil? 78.15 degrees Celsius. This boiling point of this mixture is less than the boiling point of the ethanol. Is less than the boiling point of ethanol. Do you remember the positive deviation from Raoult's law? What is the positive deviation from Raoult's law? We have learned positive deviation from Raoult's law. Or which compounds will show the positive deviation from Raoult's law? The compounds which are more volatile. The compounds which are more volatile will be showing positive deviation from the Raoult's law. Yes or no? When they are more volatile, they are going to show more vapor pressure above the solution. They are going to show more vapor pressure above the solution. Means, in other words, we can say these are, you can see the positively deviated solutions of the Raoult's law. They are going to show this kind of decrease in their boiling point. Means they are going to boil at a lower temperature. Let us explain the point very clearly. What are these kind of solutions going to be called? We are going to call these kind of solutions that they are going to boil at a constant temperature. We call them as the azeotropic mixtures. See the point here? The binary solutions that have same composition in liquid and vapor phase, and boils at the same temperature. They are called as the azeotropic mixtures. What are they called as the azeotropic mixtures? One example I have given for you here. This example, when you see, what is the composition? 95% of ethanol and 5% of water. The binary solutions, this is an ethanol, this is water, that have same composition in the liquid phase and also the vapor phase. Means we cannot separate them by the distillation method. Such kind of compounds, they are boiling at same temperature. Why cannot be separate? Means they are having the same boiling point. What is the same boiling point they are having? 78.15, which is a lesser boiling point than the boiling point of the ethanol. Why are we not considering the boiling point of water? Means once you take these two boiling points, which is having lesser boiling point, ethanol is Now, which will show more vapor pressure? The compound that has lesser boiling point will show more vapor pressure. More vapor pressure means that it is going to show a positive deviation in the Raoult's law. That is going to show a positive deviation in the Raoult's law. So these kind of solutions, they are going to boil at a lesser temperature. They are going to show the minimum boiling, they are called as the minimum boiling azeotropic mixtures. They are called as the minimum boiling azeotropic mixtures. What are minimum boiling azeotropic mixtures? The minimum boiling azeotropic mixtures are those which boils at a lower temperature. At a lower temperature than the component which exists more in the vapor phase. These are the compounds that are going to show positive deviation from the Raoult's law. So the minimum boiling azeotropic mixtures are those that shows positive deviation. They show positive deviation from Raoult's law. They show positive deviation from Raoult's law. Let us see here the second type of azeotropic mixtures. What is the first type I discussed now? Minimum boiling azeotropic mixtures. Now we are going to discuss about maximum boiling azeotropic mixtures. See, we know generally nitric acid. The boiling point of nitric acid is 357 Kelvin. In general, the boiling point of nitric acid is 357 Kelvin. But when we are going to take a mixture of nitric acid, that is around 68%, and the water of around 32%, these both are going to occur in same composition in the liquid phase and also in the vapor phase, and they are also going to boil at a constant temperature, around 393.5 Kelvin. At what temperature are they going to boil? These mixtures of nitric acid and water, they are going to boil at a constant temperature of 393.5 Kelvin. So can you call them as azeotropic mixtures? Yes, we can call them as azeotropic mixtures. But what is the point we need to observe is, among nitric acid and water, the boiling points, once we see, the boiling point of nitric acid is 357 Kelvin, whereas the boiling point of water is 393 Kelvin. Boiling point of water is 393 Kelvin. So which will be evaporating fast, or which will be going to evaporate fast? The one which is having as a boiling point will be going to evaporate fast. Yes. So we say this will be having more vapor pressure. Yes or no? But the point is, when these both are mixed at this composition, they have a boiling point of 393.5 Kelvin. You can see last time when we compared ethanol and water, the mixture is going to show a positive deviation from Raoult's law. But once you take nitric acid with water, these will form intermolecular hydrogen bonding with each other. What bonding they will form? Intermolecular hydrogen bonding with each other. We had already learned, when the two compounds are forming intermolecular hydrogen bonding, the forces of attraction between the molecules will be increased and they will show negative deviation from Raoult's law. So as these compounds are having intermolecular hydrogen bonding, they are going to show negative deviation from Raoult's law. Negative deviation from Raoult's law means their boiling point was raised. As the boiling point was raised, than one of the compound, these are called as the maximum boiling azeotropic mixtures. These are called the maximum boiling azeotropic mixtures. So these are the two simple and important concepts about azeotropic mixtures. So let us see one numeric on the previous topic that we had discussed. Let us see the in-text question, children, given in the NCERT textbook here. The vapor pressure of pure liquids A and B are 450 millimeters and 700 millimeters mercury respectively at 350 Kelvin. So here they had given in the first sentence about the vapor pressure of the pure liquids A and B. A it is 450, B it is 700. And find out the composition of the liquid mixture if total vapor pressure is 600 millimeters. Whenever we get this total vapor pressure, we know one formula, the rest through the Raoult's law only. P total means total vapor pressure is equal to partial vapor pressure, sum of the partial vapor pressures of the components, liquid components. Also find the composition in the vapor phase. So they didn't give the mole fraction here. Had they given the mole fraction, that's what we call as the composition. They didn't mention the mole fraction. But we are going to find out the mole fraction, that is the composition of the liquid mixture. And also we are going to find the composition in the gaseous phase. So these are the tasks we need to have. Mole fractions we need to identify now. So let us see here their composition. How to see the partial vapor pressure of the component A. How is it given? The partial vapor pressure is directly proportional to mole fraction of the component we have discussed from the Raoult's law. So this is also given as P is equal to P1 naught into X, or we can simply say P naught. P naught is the vapor pressure of pure liquid substance. X is the mole fraction. Is it not? So based on these formulas, we are going to derive like PA is equal to PA naught into XA. And how do we give PB? PB is equal to PB naught into XB. So first our task is to apply these two values into the formulas. So once we go and apply the values, what do we know? P total. What is the value of P total given? P total is given as 600 millimeters of mercury. We know PA naught into XA plus PB naught into XB. Here I want to take one key point, that is the sum of the mole fractions will be equal to 1. If you want to know about only XB, we can also write this one as the 1 minus XA. Can you write this one as 1 minus XA? So once I want to explain the point here, then we will go into the formula. So PA naught into XA plus PB naught into XB. This XB I want to write as 1 minus XA. I want to write as the 1 minus XA. So can you write this one as PA naught into XA plus PB naught minus PB naught into 1, that is PB naught, minus PB naught into XA. See, these two terms are related to the XA. PA naught minus PB naught of XA plus PB naught. What is this is explaining? This is explaining that the total vapor pressure can be dependent upon mole fraction of one of the substance. Can be dependent on mole fraction of one of the substance. So if you know the mole fraction of one of the substance, obviously we can get the mole fraction of another substance. So we are going to substitute the values here. How should we substitute the values here? So P total. P total is how much we got? 600 millimeters mercury. PA naught. PA naught is how much we got? PA naught they have given 450 millimeters minus PB naught. How much is the PB naught? 700 they have given. Okay. Into XA. We don't know value of XA. Plus PB naught. What is the value of PB naught? 700. So once we are bringing this 700 on the left hand side, we can also write as 600 minus 700, or directly you can write as this 100. So I want to write as 100 is equal to 450 minus 700. So it is around minus 250. See here, 600 minus 700 we get that. So here we get minus into XA. If you want to have the XA term, we can write this as minus of 100 by minus 250, or we can simply write this as XA is equal to 0.4. What is the mole fraction of XA we got? 0.4. But what do we know? The sum of mole fractions of the two components will be equal to 1. So once you got the XA, then you could see XB is equal to 1 minus 0.4. So it will be like, this is due to XB is equal to 1 minus XA. From there we can write this as XB is equal to 0.6. So up to now we are able to derive the mole fractions. So we are going to substitute these values of XA and XB into our equations. That is, the PA is equal to PA naught into XB. What is the PA naught value we had? 450. So 450 into 0.4. Then PB is equal to PB naught into, sorry, this is XA children, XB. This is what? 700 into 0.6. So once you please observe these values and please help us to do. How much we are getting? This is around 180 and this is around 420. Is it not? So these PA and PP are the compositions. Are the compositions of the liquid mixtures. But they are asked also to find the composition in the vapor phase. Means if you want to know the mole fraction of A in vapor phase. In vapor phase, we can get its composition by taking its pressure. So the mole fraction of A in vapor phase can be given as PA by PA plus PB. What is the PA value we got? 180 by 180 plus 420. Approximately we will be getting 0.3. Means the mole fraction of A in vapor phase is 0.3. Then what is the mole fraction of B in vapor phase? Mole fraction of B can be written as 1 minus mole fraction of A. That is equal to 0.7. So these are the mole fractions in the vapor phase. The only thing is, when their mole fractions are not given, you must remember this formula. Means the total vapor pressure is dependent upon mole fraction of one of the component, and we can derive the solution. Thank you, Shamil.